Hello everyone. Last time, we introduced the structure and assembly of the instrument panel and the auxiliary instrument panel. In this chapter, we will learn the structure and working principle of the air conditioning system.
Structure and working principle of air conditioning system of automobile. 1. Overview. No matter what the weather conditions outside the automobile are, the air conditioning system designed provides a comfortable environment for passengers. The system controls the air entering the passenger compartment by performing the following functions: cooling, drying, warming, and circulating. The air conditioning system has the following features: regulation of temperature, humidity, and cleanliness, and defrosting of front and rear windscreens. The driver can select any of the following functions from the AC control panel: in-car temperature, HVAC blower speed, air outlet mode, internal and external circulation. The fresh air enters the car from the inlet hood, passes through the AC filter, HVAC assembly, and air pap, and then arrives at each outlet to enter the car space. The air conditioning system consists of the following main components: cooling system, heating system, ventilation system, and air conditioning control system. The specific structure is shown in Figure 32421. 2. AC cooling system. The AC cooling system is used to lower the temperature and humidity in the car. The gaseous refrigerant is drawn in through the compressor inlet and then compressed. Then the refrigerant is heated to 70 centigrade to 110 centigrade. The compressed gas is pumped into the condenser. The condenser is composed of many heat skins for air to flow through, so that the compressed gas can be fully cooled by the outside wind and the air from the condenser fan. The cooled refrigerant is stored in the dryer. As the concentrated liquid refrigerant passes through the expansion valve, the pressure and temperature drop rapidly, and some of the refrigerant evaporates. The expansion valve is just in front of the evaporator in the refrigeration pipeline, while the refrigerant is completely evaporated in the evaporator. Because the evaporator is cold, the air passing through it also will be cooled. Basic conditions for normal operation of the AC cooling system. A. The outdoor temperature is greater than zero temperature. B. The evaporator temperature is greater than the frost protection valve. C. The pressure of the air conditioning system is normal. D. The AC blower starts normally. E. The engine control unit operates normally. F. The control line is normal. See this figure for the structure of the AC cooling system. It consists of condenser, compressor, blower, evaporator, expansion valve, dryer, and fan, etc. 3. AC heating system. The AC heating system is used to increase the temperature in the car. The winter or early spring, the temperature difference inside and outside the car is large, and the car glass will frost or fog. The heating system can be used for defrosting and defogging. According to the different heat resource, the AC heating device can be mainly divided into water heating device, air heating device, and independent combustion type heating device. The water heating system is generally composed of control switch, blower, heating water tank, circulating water control switch, and corresponding pipeline, as shown in the figure below. When warm air is needed, switch on the control switch, and the circulating water control switch, it will be automatically switched on, so that the coolant of the engine begins to circulate in the heating water tank and pipeline. With the running of the water pump, the engine coolant flows into the heater core. When the heated engine coolant circulates in the heater core will become hot, and the air flowing through the heater core will be heated into warm air and blown to the car through the air outlet. The schematic diagram of the working principle is shown in the figure below. This heating device is featured with simple structure, low energy consumption, low cost, and convenient operation and maintenance. Thus, it is very popular among various automobiles. 4. AC ventilation system. The AC ventilation system of the automobile performs as follows. When the automobile is running, it introduces a certain amount of fresh air from the outside and discharges the air inside the car out of the car. Meanwhile, it can prevent the windscreen glass from frosting. The air circulation inside a car is shown in the figure below. Generally speaking, there are three kinds of ventilation mode. 1. Dynamic pressure ventilation, also known as natural ventilation. By setting air inlet and air outlet at appropriate positions, it takes the wind pressure generated on the outside of the car body when the car is running as the power to realize ventilation inside a car. 2. Forced ventilation. It uses a blower to send the air outside the car into the car in a forced way for ventilation. Generally, the device combining ventilation, heating, and cooling is used on cars with a cooling and heating device. These cars are generally equipped with 5 functions. Stop. Natural ventilation. Natural circulation of air inside and outside the car through windows. Air intake, exhaust, and circulation. 3. Comprehensive ventilation. It means dynamic pressure ventilation and forced ventilation are applied for a car simultaneously, and they can be used at the same time or separately as needed. The AC air distribution system of cars generally consists of 3 parts. The first part is the air entry section. It mainly consists of damper plate and servo, used for controlling fresh air and indoor circulating air. The second part is the air mixing section. It mainly consists of the heater and evaporator, used for providing air at required temperature. The third part is the air distribution section. It blows the air to the face, feet, and window glass. Its air outlets are shown in figure 32426. 5. Structure and working principle of components of air conditioning system. See figure 32427 for the overall structure of air conditioning system of automobile. It consists of outside temperature sensor, condenser, air conditioning pipeline, air conditioning pressure switch, and compressor. 1. Outside temperature sensor. The outside temperature sensor is used to measure the ambient temperature outside the car. The resistance value between 2 terminals decreases with the increase of the ambient temperature and increases with the decrease of the ambient temperature. Resistance value range under normal temperature. Ambient temperature 10 to 25 centigrade. 10 kiloohm to 5 kiloohm. See figure 32428 for its outline. 2. Condenser assembly. The high pressure and high temperature refrigerant steam from the AC compressor flows into the condenser, composed of aluminum tube allowing to the rapid heat transfer of high pressure and high temperature refrigerant steam and cooling fins. The cooling fins condense the high pressure and high temperature refrigerant steam into high pressure and medium temperature liquid through heat dissipation. The receiver or dryer is located on the left side of the condenser. The internal structure design of the receiver or dryer can ensure the entry of high pressure and high temperature gas and liquid refrigerant, while only the high pressure and medium temperature liquid refrigerant is allowed from the receiver or dryer. There is desiccant inside the receiver or dryer to absorb moisture of the cooling system. The desiccant cannot be reused. See figure 32429 for the condenser. 3. Air conditioning pipeline assembly. The air conditioning pipeline connects various parts of the air conditioning system to form a complete set of automobile AC cooling system. It is generally composed of aluminum pipe, rubber pipe, pipe joint, seal ring, pipe clamp, and filling valve, and so on. It required that the air conditioning pipeline has good shock absorption effect and can withstand high pressure, so as to ensure the sealing reliability of the air conditioning system and ensure that the refrigerant will not leak, as shown in the figure below. 4. Air quality sensor. The air quality sensor is installed near the air inlet of the air conditioning system to detect the quality of air entering the car when the automatic internal and external circulation function is enabled. If it is detected the quality of air entering the car becomes worse, the external circulation of air conditioning will be changed to internal circulation so as to avoid the air inside the car being polluted. See figure 32411 for the air quality sensor. 5. HVAC assembly. The HVAC assembly is located in the instrument panel and consists of HVAC blower, HVAC blower motor speed governor module, dust filter, heater core, evaporator, expansion valve, mixed damper control motor, and virus air deflector damper and ventilation duct. Its structure is shown in the figure below. 6. Sunlight sensor. The sunlight sensor is directly connected to the automatic air conditioning controller, and its output voltage changes according to the sunlighting density. When the sunlighting density increases, the output voltage decreases. When the sunlighting density decreases, the output voltage increases. See figure 32413 for its outline. 7. Inside temperature sensor. It is used to detect the temperature in the car, with one end connected to the HVAC assembly and the other end connected to the instrument desk trim panel. When an AC blower is in operation, the air is sucked by HVAC system through the instrument desk trim panel grill to detect the airflow temperature in the car. The resistance value between two terminals decreases with the increases of temperature, and increases with the decrease of the ambient temperature. Resistance value range under normal temperature, ambient temperature 10 to 25 centigrade, 4.2 kilo ohm to 2.1 kilo ohm. See figure 3 to 4 to 14 for the inside temperature sensor. 8. Air conditioning pressure switch. The air conditioning pressure switch is a kind of three-state pressure switch that transmits air conditioning pressure signal. Its structure is shown in figure 3 to 4 to 15. 9. AC compressor. The AC compressor is driven by the engine crankshaft by driving the compressor clutch pulley through the belt. When an electromagnetic clutch coil is not energized, the compressor pulley rotates freely and does not drive the compressor shaft. When the clutch coil is energized with voltage, the clutch disc and then the hub are pushed to the pulley, and the magnetic force locks the clutch disc and the pulley as one to drive the compressor shaft. The compressor will be shut down under the following condition. 1. The throttle valve is fully opened. 2. Lower idle speed. 3. Low ambient temperature. 4. Too high coolant temperature. 5. Refrigerant pressure is higher than 3.28 or subtract 0.2 megapascal or lower than 0.28 or subtract 0.02 megapascals.
Okay, that's the end of the structure and the working principle of the automobile air conditioning system. Have you got it? Please preview the assembly of the air conditioning system according to the work order. See you next time.